So in this example, this is a word problem that we're going to be using probability in our standard or normal distribution to answer this scenario. Anytime you come across a word problem, you should certainly make sure that you read it carefully so that you know exactly what's being asked. So this one says, suppose Dup's Potato Chips Company manufactures an 8-ounce bag of potato chips. The distribution of the weight of bags manufactured is approximately normal, with a mean of 8 ounces and a standard deviation of 0.21 ounce. A local store chain orders a shipment of 1,500 bags of Dup's potato chips. So a couple of things to point out. When Dup's makes their 8-ounce bag of potato chips, on average, the bag is 8 ounces. So we have that right here with a standard deviation of 0.21 ounce. And then, of course, we have this store chain. They're ordering 1,500 bags of chips from Dup's potato chips. So when they order that 1,500 bags of potato chips, A asks how many bags of chips will be less than 7.5 ounces. The interval that would express letter A here, how many bags of chips will be less than 7.5 ounces, that'll be an interval that would look like this. It would be negative infinity to the 7.5 ounces. So that's our interval. So we're going to go ahead and use our probability calculator here. Of course, this is set at our standard settings of a mean of 0 and a sigma of 1. We're going to go ahead and change this to our 8 ounces, a mean of 8 ounces, and a standard deviation of 0.21 ounce. So now this distribution represents this scenario here. So if I want to know what this interval is here, I'm going to go right here. This is the interval in question. Here's our bracket here. And then I'm going to type in 7.5 ounces. And we hit enter. And that's 0.0086. So that's a percentage of 0.86%. So a very small percentage. You could see the area that represents it is very tiny. But the question asks how many bags of the 1,500 will be less than 7.5 ounces. This tells us the percentage that will be that. We want to know how many bags. So I'm just going to take the 0.0086 written as a decimal and multiply that to the 1,500 bags that the chain store is ordering. That comes out to be 12.9. So it would be fair to say that approximately 13 bags. So for letter B, if the chips must be within the middle 80% of the mean weight before the store will accept the order, what weights must the bags be between? So when this store chain orders the 1,500 bags, all of those bags have to be within 80% of the mean weight. So we have to figure out what that interval is. So as we look at our calculator over here, our probability calculator, this is going to be with some sort of bracket like this. So this is going to be this interval right here. This area here, the middle, and the middle is centered right over the center, right over the mean. We want it to be 80%. So if you could grab these little observation levers here, these little tabs, and you can adjust them. And as you move them back and forth, you can see the area right here adjusts. So I'm just going to kind of slide these until I get close to, there's close to 80%. But I want to make sure that when I do that, it's centered perfectly right over the center. So you could be spending a lot of time adjusting these little tabs here. So I've got a simpler way, a more direct way, actually a couple of ways that we can do this so we can get it exactly. The first thing I'm going to do is I'm going to change this to the standard. I'm going to make mean 0 and the standard deviation of 1. And I'm going to set the first interval here, this one right here, I'm going to set it to 0. That way, all I have to do is adjust just one of these levers here. Because if I want the middle 80% in here, I'm just going to find 1/2 of it. Whatever that is on going this way, it's going to be the same amount going the other way. So I'm just going to adjust this to around 40%. I'm going to try and get it as close to 40 as I can. Whoops. See, I'm going to try and get as close as I can. That's about as close. See, it's a little sensitive, so it's hard to kind of get it exactly. But that's pretty close. But I want to get it as exact and as possible. So now what I'm going to do is it's close to 1.2452 standard deviations. I need it to be a little bit bigger. So I'm just going to kind of go ahead and put it 1.26. How about if we do that? So we're getting closer. So I'm going to change that to 1.28. And there it is at 0.3397. Now I'm going to change it to 1.29. Now that's too much. So maybe do 1.281. So that's 0.3999. So I'm going to do 1.282. And I'm just kind of fudging it, using the entries here to do it rather than moving the tab with my finger here. So it's close. 1.281 is 39.99%. 1.282 is 40.01%. So I'm going to try in between there, 1.2815. How about that? And look at that. So 1.2815 this way. So then if I move this one to negative 1.285, and I'm just going to type it in there. And there's my 80%. So the interval that will give me the middle 80%, if the chips must be within the middle 80%, goes from negative 1.2815 to positive 1.2815. But these are the z-scores. I need to know the actual weight of the bags. So we know that a z-score that's equal to some observation, that's x, that's what we're looking for, minus the mean divided by the standard deviation. Well, if I have a z-score of negative 1.2815, I'll do that, negative 1.2815. That's going to be equal to x, which is the observation I'm looking for, minus the mean, and the mean, that's 8 ounces. Divide that by the standard deviation, that's 0.21 ounce. So now with a little bit of algebra, all I have to do is solve for x. So I'll multiply both sides by 0.21, so this comes out to be negative 0.2691. That's equal to x minus 8. And then I go ahead and I add 8 to either side. So negative 1.2815 is a z-score. Well, as a raw data, it's going to be 7.7309. I do the same thing for the positive one. 1.2815. That's equal to x minus mu, which is 8, divided by the standard deviation, which is 0.21. This is going to be positive 2691. Go ahead and add 8. So then x is going to be equal to 8.2691. So the interval, if the chips must be within the middle 80% of the mean weight before the store will accept the order, what weights must the bags be between? They must be between 7.7309 ounces and 8.2691 0.2691 ounces. And there we go. Now letter C says, if the store will only accept the order if the chips are within the middle 80% of the mean weight, how many bags of chips should Dupps manufacture to ensure the store will accept the order? Now the store wants 1,500 bags, but according to its distribution, only 80% of the bags will fall within these weights right here. So Dupps has to make more than 1,500 because a certain percentage are not going to be accepted. So all we have to do is we have to determine 80% of how many have to be made to give me 1,500. So we just solve for X. So Dupps should make 1,875 bags because 20% of them will be thrown away, leaving 1,500 bags. So it should be 1,875 bags.